Today's topic is solid state physics. So, to understand solid state physics, you can take help from these books. These books are really good. So, first one is a kettle, second is the Astropt Marvin, third is Puri Babur, which is by the Indian author, and next is Ali Omar and M.A. Wahab. So first three books are mainly important. So Kittel is a very nice book. Astronaut Marvin is also a very standard book. Puri Babur is very nice for like understanding and all. So in your CSIR net, there are 15 to 23.5 marks will come from the solid state physics, and in GATE there are 8 to 10 marks will come. So now I am starting the chapter. So first we will start from what is matter. So there are different states of matter, like first one, which is solid, because the state is solid. Next is liquid, next is gas, and the fourth state we can call as plasma. So our main interest is this solid part. So yeah, this part. So if we further study solid, so we can get there are several parts like crystalline, solid, and also the non-crystalline or amorphous. And if we further study crystalline, like, then we will get single crystal and polycrystal. So what is the difference between solid, liquid and gas? Solid is the most condensed phase of the matter, and uh, further if we go to liquid, it is less condensed phase, and in gases the atoms molecules are very far apart. In gas, if we divide it, like, it will be like atomic gas and molecular gas. Atomic gas means what? Atomic gas means when the gas is self an atom, like helium, neon, argon. These are the atomic gases, and so on. Okay. And if it is a molecular gas, means the gas will be will it be a molecule, like hydrogen, oxygen, nitrogen, and etc. So in gases, interaction between atoms is very weak. That's why they can move randomly here and there. They perform the translational motion, and obviously here is a gas, here is a gas, and here is a solid. So in between there is liquid. So the attraction force interaction between the atoms is in between solid and gas. That is not much more um, strong interaction, or not as weak interaction, like medium type of interaction. So if we if we show interaction between the atoms, so the interaction will be more for solid, then liquid, and then gas. In solid state phase, atoms and molecules are very closely packed. So our study is about the solid. So now we can say the solid state phase. In the solid state phase, the atoms and molecules are very closely packed, like they can touch each other. Atoms will be considered as hard sphere, and if they have the radius r, which is r means the distance from nucleus to the outermost orbit. The interaction between atoms is so strong that they can touch each other. In gases, this distance is very large. The interaction between the atom is very weak in gases. Like if we take sodium, sodium as an atomic solid. So there is an atomic radius of sodium. If we can take it as r, and if we take NaCl, then it will be NaCl is a molecule. So this will be called as molecular solid. And here there will be two radius. First is radius of Na, and second is radius of chlorine. So the center to center distance is called the internuclear separation, or it can be called as the bond length, or interatomic distance, equilibrium distance, or nearest neighbor distance. Nearest neighbor distance. So there are so many names of the same thing. So you have to remember all the names, because in the questions, whatever uh, name, whatever term will come, you have to understand that it is considering the same thing. So now, if I divide the solids by their properties, first there will be everything is here is the same thing, like everything is R. So the same thing, bond length, interest, everything. So next we will start the crystalline solid. In a crystalline solid, atoms and molecules are arranged in a regular or periodic manner. It can be in 3D or it can be in 2D also. So the thing is periodic manner. So obviously there will be a non-crystalline thing. So non-crystalline, or we can call it amorphous. So what is amorphous? Obviously, which are not arranged periodically, rather arranged randomly. So it has no certain pattern. Example, glass, rubber, and many more. So now we will highlight this part, that is crystalline solid. So now we will, okay. So crystalline solid can be many types, like single crystalline or single crystal. Single crystal means single crystal is characterized by only one type of arrangement throughout the solid. So throughout the solid, this is just one type of arrangement. Example is diamond, or there are many more example like quartz, but it's very rare to find single crystal in nature, or you can produce single crystal by different mechanism. So these are natural single crystal like diamond and quartz. These are natural single crystal. Single crystal means there is no break. If there is any break, then we will call it as two crystals. Like if the diamond breaks, then we will call it as like two crystal, not one crystal or not single crystal. Okay, so next is the polycrystal or polycrystalline. It is the aggregate of large amount of single crystal. So this is found naturally. So many single crystals which are very tiny and they are at together. So the example like anything, sodium, potassium, copper, gold, these are all metals. And if we are called like if we take semiconductor, this will be like silicon. Whatever abundant in nature, everything is polycrystalline. So if we want single layer of silicon, means single crystalline silicon, so we cannot get it in the nature. It will be found in polycrystalline form. So what are the properties of the solid these materials? So there are some physical properties. Number one is thermal. Next, electronic properties. Next is some magnetic properties, some optoelectronic properties, some dielectric properties, some mechanical properties also, and so on. There are so many properties. Okay, if you are having same type of atoms in different arrangement, they have different physical properties. Means the physical property will depend on the structure of the material. So structure played an important role here. Structure is very important thing here. So you have to study the structure. Like I have carbon atom. So carbon atom, suppose you have graphite and you have diamond. So there is so much difference in graphite and diamond because they have difference in their structure. So what will be the differences? Like first, first is the electrical or thermal thing. Okay, let's say first is a thermal thing. The graphite is thermal insulator, but diamond is thermal conductor. This is thermal. Okay. Next is this is thermal insulator and this is thermal conductor. Diamond is. And okay, I will write like this. So graphite is thermal insulator, but diamond is thermal conductor. Graphite is electrical conductor. Okay, but diamond is completely different. So diamond is thermal conductor and electrical insulator. Okay. So the crystal structure determines the physical properties. It determines the physical properties. Okay, remember. This is something. What can I say? Okay. So, so crystal structure is very important, and this crystal structure is studied in crystallography. So this is crystallography. Next day we'll start crystallography.